Hi, virtual students. We're talking about equilibrium here today. So we're going to combine the supply and demand curves. They're going to make an X. As we're going through this, you're going to fill out the notes that look like this. You'll kind of see each new graph and slide that I pull up, you'll kind of draw what I draw. And then we'll get to about this point. We'll stop here and then finish it off on the next video. So that's where we're at. Let's go ahead and get started. We're kicking you off with a daily blog here. Go ahead and get your answer for those. Let me pull this up. Go ahead and get your answer for those, and we'll talk about the answers here in a second. Okay, so we're looking at this here, and all it's having you do is talk about and identify the the prices and quantities as these curves see some changes. So number one, what's the quantity demanded at $4? We're right here. Okay, so at this point, our quantity demanded at $4 is 12. Then it asks, what if the price is set at 6? So we're just matching this point. The quantity demanded is 9. It's reminding us that as price goes up, we demand less. Over on number 2, we're talking about what is the quantity supplied at $6, which we have 5. What's the quantity demanded at 12? I'm sorry, quantity supplied at 12. It's 9. That's representing that, as my wage could potentially go up, I'm more willing and able to supply something, produce something. And then over here on number 3, how much is demanded at 12? We've got a low number, 3. How much is supplied at 12? We've got a higher number, 9. All right. And then it asks us at 8, how much is demanded and supplied? We've got kind of that perfect point, which is, again, what we're going to eventually get into here today. And we're going to call that point equilibrium. Okay, so go ahead and give yourself a chance to write this definition down. Layman's terms, it's going to be where where supply and demand intersect each other. Okay, now eventually we could use the book term and say this is the point where buyers and sellers agree and prices are eventually going to be set. We'll kind of talk about how that occurs as we move forward here. All righty, so easy to identify. On that first graph, as you've seen, go ahead and write in what is filled in for you. So our equilibrium point, like we said, is where supply and demand intersect. Right here is our equilibrium quantity. I'm just going to label it with a Q star. All right. Our equilibrium price lines up over here. I'm just going to label it with a P star. All right. And again, this is the point where, if you want to think about it like a grocery store, maybe where there's a reason why the grocery store doesn't usually run out of stuff, and they don't usually have piles and piles and piles of stuff backed up because they set that price just right in a lot of situations. And if they don't, we know they put stuff on sale. They might raise the price of stuff sometimes. So we know that occurs as well. Now, sometimes we set the price incorrectly, so to speak. And you're moving on to your second graph here. So sometimes we set this price incorrectly. So when we do that, what occurs is we already know. Okay, so if I'm trying to sell something and I say, hey, listen, I'm going to set this price at whatever. I have some labels on these, all righty. And we know it kind of experienced it back in the beginning of COVID stuff when toilet paper was like running out on shelves, right? Well, the challenge with that is our demand had moved. Well, when our demand moved, we didn't adjust the price. Okay, so our price stayed down low. And as we kind of think about what's going to happen, like, okay, well, what's going to happen if everybody buys all the toilet paper? Well, we're going to run out of toilet paper, right? That's what our common sense is going to tell us. Now, what our graph's going to tell us, all right, is that we have a quantity demanded here, which on my graph, it equals 425. We have a quantity supplied here, which on my graph equals 150, okay? And our quantity demanded is bigger than our quantity supplied, okay? So the fancy econ term for that is we're going to have a shortage. And like I said, the common sense of it is, oh, we know we're going to run out of stuff, right? If something's really popular and if we keep the price really, really low, think about what happens on Black Friday too, right? They have an equilibrium point for Black Friday. They set the price way low to get rid of stuff. If you ever gone to shop for something that's really cheap, you know that if you don't get there fast, they run out of stuff. right? So we know this happens. We've never used it on a graph, right? But we know this shortage happens. We're just kind of changing the verbiage that you would use if you were talking to somebody about things. On the flip side, okay, if we were to set the price too high, and I'm going to start off here. I'm going to kind of label some things. So I'm going to give my price axis some numbers just for the sake of being able to visualize what's going on. I'll do the same for my quantity. And you're moving down to your next graph here, so you should be able to see where you're at. Now, let's on the flip side say, hey, listen, I really think people are going to want to buy the stuff that I'm selling, right? And maybe that would be something like, oh, I don't know. Um, if Starbucks raised their prices because they thought that they were going to get more high school kids go across the street to buy stuff, right? So Starbucks gets built across the street from a high school. Oh, these kids are really going to want this because they can't get anything inside the high school anyway. So we're going to set our price for Starbucks drinks up at $6. All right. Well, we have a quantity supplied here, right? So they think they're going to sell a lot. So they're going to work hard at it. So at my graph, it equals 425. We also have a quantity demanded. And again, I can choose to buy coffee if I want to. You can choose. And our quantity demanded is 125 at this point. Well, in our words, like, hey, if they charge you $6 for a Starbucks drink, you're like, ain't nobody going to buy that, right? So in this case, the opposite happens from when we have a shortage. We have our quantity supplied is bigger than our quantity demanded, and it creates a surplus. Okay, so in our general verbiage in day-to-day talk, we're going to say, oh, they're not going to sell any of that stuff. Well, it's simply just a surplus. Okay, no one wants to buy nearly as much as they're willing to sell. Kind of like I said, proven common sense with these graphs. I know the graphs are a little bit tricky, especially the first time we're seeing them, but we're proving what we know. Okay, as we're getting into this stuff. Okay, now there are some cases, and we'll get into here in a second. There are some cases where um, we shift our lines, right? We spend a lot of time with that. So go ahead and here take a quick second to answer the questions number 1 and number 2. All right, let's talk about what we are looking at now. First of all, we had this acronym. It's a good time to remind us of this acronym. Well, let me write on that. So increase right, decrease left, right? And so we'll bring that up here again in a second. But either way, so we use that acronym of ERDL, right, to help us remember which way we're shifting stuff. All right, so for number 1, we're looking at the original equilibrium price, 10, original equilibrium quantity, 10, and then we have an increase in demand, right? So we shift our demand to the right. What is the new equilibrium price? So now people really want to buy stuff, okay? Think silly bands back in your kindergarten days. And so what we can assume is going to happen is our price is going to go up, in this case to 14, and also people are going to start buying more of those things because they're super popular. Our quantity is going to go up as well, in this case to 15. All right. Number 2, we're moving the supply to the right. So we've got an increase in supply. First, our original equilibrium point gives us a price of 4 and a quantity of 8. So some things that might increase our supply. Well, we've got like a super good weather year, right? And maybe that just means there's tons and tons and tons of corn or tomatoes available, whatever. Think about like sweet corn in late August. They have tons of that compared to normal times of the year. So what do they do with the price? Well, they lower the price, in this case to 2. And there's also way more available. We know that. In this case, it's at 11. Okay, so being able to see those graphs, realizing how they're lining up with the axes is important as we move forward. Just a quick reminder, here's our shifters that we wrote down on a previous part of this unit. You might want to have those in front of you. I kind of reference them as we go through. You don't really need them for this part of the assignment, but anyway, that should be pretty straightforward. All right, so let's start here. You are back on the back side of these notes, and you'll see that you're starting with the increase in demand. Okay, so they're labeled for you. You'll see what you've got to do. Fill out like the labels for you. And again, there's a reason I left them blank so you can get some practice, get used to seeing them. Okay, so first thing, and you can see I used to talk about silly bands here, but I have a great opportunity to talk about something that we're all extremely familiar with. That on March 14th or thereabouts, our governor or maybe our mayor, whoever it was, decided that we had to wear masks in public. And that completely changed things. So what I'm doing here first is I'm identifying our original equilibrium price and equilibrium quantity. When we got to that point that we had to wear masks, well, all of a sudden we had to buy masks. So our demand for masks goes up. The government says so, right? We've got a new demand. And if I were to ask you what's going to happen if the government says we have to wear masks, like, well, you're like, well, hey, I need to figure out a way to sell masks because the price is going to go up, right? And we know a lot of companies did that. So we get a new equilibrium quantity. I'm just going to call it Q1. We get a new equilibrium price. I'm going to call it P1. Okay. And every time, what this graph is going to show us that if we can identify a reason for something to increase the demand for something, that our price is going to increase as well as our quantity. And I've got a little spot you can kind of add to that you can halfway use another way to try to memorize what's going to happen. Now, let's go on to the next one here. We also have situations where obviously our demand is going to be decreased. Get my original price and quantity here just so we can see it. Okay. So for example, I have flip phones up there. So if you're familiar with kind of the evolution of smartphones, obviously they go from flip phones, slide phones, whatever, and eventually obviously to the smartphones we have now. So if you once we knew that smartphones were super valuable, we stopped wanting flip phones. And we still know some people that have flip phones, usually some crazy uncle or something like that, right? And so we have a decrease in demand for flip phones. And we're like, well, we know that the price of flip phones is going to have to go down, right? Flip phones are going to have to become cheaper, otherwise they're not going to be able to sell them. And we also know less people want them. Okay, so we can say that anytime there's a decrease in demand, the price of something is going to decrease, the quantity is also going to decrease because now people don't necessarily want those things. Okay, let's flip things over and go to the supply side. So throughout our especially recent history, computer technology has increased extremely significantly, right? And if you're familiar with the evolution of computers, this is one of the first computers made right here. You can see how big it is, and I think it had the storage capacity of like 500 kilobytes, which your phone holds probably 64 or 128 gigabytes. So 500 kilobytes is kind of about the equivalent power of one of those small little solar powered calculators, and that thing cost $50,000 to make. So obviously the technology going into computers has increased significantly, right? So we've got a change in technology here, right? So that's how I'm lining this up. And we're going to increase our supply, all righty? Well, what's that do to our new equilibrium price and quantity? Well, our equilibrium price goes down and our equilibrium quantity goes up. So as it becomes easier to make computers, we get a whole lot more of them. And we also see the price decrease. Okay, so they become obviously more affordable for us. Okay, let's go last but not least here. Let's decrease our supply. So let's say that there's just like a flood or a natural disaster. A little bit more recently, there was a situation where some romaine lettuce got diseased by E. coli. And so any of those natural disasters, we can kind of tie into this to describe a decrease in supply. So Ertl tells us decrease left, right? We're going to shift our supply to the left. And when that when that romaine lettuce got diseased, well, it didn't disease all of it, but a lot of it. So we had less. We were able to charge a higher price for it. We also know the quantity also decreased, and we can show that on our graph. Okay, so what these are showing us, like it's showing us some common sense. Again, like I said, the graphs aren't necessarily common sense, but we're using them to prove what we already know as experienced capitalists and experienced, Americans, especially in the American economy, but other economies too, where prices can adjust. Okay, hopefully this makes sense for you. If not, email me with questions. Keep grinding it out, and we'll talk soon.